I'm going quickly because I'm figuring you can always stop the tape and go back, or stop the video, go back and look at it again. And so if I just sort of move through it, you can adjust it to your own speed. So now here this says, find the measure of the indicated angle that makes lines U and V parallel, and justify your answer with a full sentence or the name of a postulate or theorem. Here's the important thing here. I don't know that these lines are parallel, so I can't use, in this case, the corresponding angle theorem. These are corresponding angles, okay? But I don't know that they're congruent because there are parallel lines there. But that's not what it asks me anyway. It asks me to find the measure of the indicated angle that makes the lines parallel. Well, here's what I know. The corresponding angle theorem converse, right? The converse says, if the angles are congruent, then the lines are parallel. So the corresponding angle theorem converse tells me that this is 113 degrees. Okay. These are alternate interior angles. I don't know that the lines are parallel, but I want to find out what would make them parallel. So this is the alternate interior angle converse that tells me that if this was equal to this, they would be these lines would be parallel. So if I make this 128 degrees, the alternate interior angle converse tells me that the lines are parallel. These are alternate exterior angles. I do not know whether or not the lines are parallel, but I want to make them parallel. So I've got to take the alternate exterior angle theorem converse and use that. And that says that if the alternate exterior angles are congruent, then the lines are parallel. So this is 110 degrees. If I make that 110 degrees, these two will be parallel lines. And here, this is actually the same. It's the alternate exterior angle converse, right? Because again, these are alternate exterior angles. And that means if I want the lines to be parallel, that has to be 97 degrees. Okay. These problems, because there's no real algebra involved, look at first like they're really simple. I just have to write this in here. But they're not. Well, they are if you know what the converse means, right? And if you recognize that it's the converse of the theorems that you have to use in order to make these lines parallel. Okay, that's what's critical here. All right, we're almost done. Find the value of x that makes the lines parallel. This is where the algebra comes in. Okay, this is the same side interior angle postulate converse. Okay, and that's what tells me that 31x minus 2 plus 60x has to equal 180. Combining like terms here, 91x minus 2 equals 180. 91x equals 182. And divide both sides by 91, I get x is equal to 2. Okay. Here, these are same side interior angles again. So it's the same side interior angle postulate converse that tells me that 24x plus 4 plus 20x has to equal 180, which means 44x plus 4 has to equal 180, which means 44x is equal to 176, which means that x is equal to 4. Because if I divide 176 by 44, I get 4. So x is equal to 4. 2 more to go. Okay, these are alternate exterior angles. Alternate exterior angle theorem. Converse, right? Because I'm trying to make the lines parallel. I don't know that they're parallel. But I do know that if these two angles were congruent, then the lines would be parallel. That's what I want. So I make this 119 is equal to 17x. And then divide them. 119 divided by 17 is equal to 7. So that's equal to x. And then finally over here, these are alternate interior angles. And I have the alternate interior angle theorem, right, that says that if the lines are parallel, these two will be congruent. But I don't have that. I want to make these parallel. And the way I can do that is to show that these two angles are congruent. So if 105 plus x is equal to 99, then x is equal to, what, negative 6, subtracting 99 minus 105. And if x is equal to 6, then the lines are parallel. That's the alternate interior angle theorem converse. And that's the packet.